I can't.
You do this every day.
I know. I got issues. Okay, so that's 80, that's 21, that's P, that's 21, it's the Q. Those are all my factors. Now, if I take 1, 2, 4 and all the top and I divide it by 1, I'm left with that. Correct?
Yeah.
Now I have to take every one of the top and divide them by 3. That's 1/3. That's going to be 2/3, 4/3, 5/3, 7/3, 8/3, 10/3, 16/3, 20/3, and ... You with me? I'm not going to name them all.
What did you get the 7/3 from?
There's no 7 on top. You're a magician.
Oh, I meant, what are you talking about? There's no 7/3.
I don't see it.
It's the reason why I said I was thinking of the 7 down here. I'm sorry. Okay, so good catch. There's more. I'm not going to finish it. Okay, I'm just making this point very clear to you. Okay, then we have to do with the 7. 1 7, 2 7s, 4 7s, 5 7s, 8 7s, 10 7s, ... Yes? You cannot do ... on your paper. FYI. I want to make that clear.
But you said whatever you do.
Dude, no. Back to train up. You're about to be speed bump. Okay?
Don't lie to us.
Now, 1/21, 2/21, 4/21, 5/21, and 8/21, ... Okay? So all 5,000 P over Q values. You with me? You're welcome. Try to be loving. Okay? So much fun for me. Okay? Now, that's my P over Q values. Now, my P over Q window is going to be what? Well, my highest one is 80, and my lowest one is? So negative 81 to 81. That's going to be my window. Yes? Which means now what do I do? And now I need to do my Descartes, right? So Descartes says I need to do my positive roots. Well, my positive roots means I'm going to count my sign changes. There's 1, there's 2, there's 3, there's 4. So I'm going to have how many positive roots? 4, or 2, or 0. Because 2 minus 2 is 0. 0 is the number that you're allowed to have, right? Now I need to do at that negative x. Well, what changes? Even or odd powers. So 21x to the 4 stays. That changes to positive 68x cubed. That stays. This changes to positive 276x. And this 80 stays. Do I have any sign changes? There's absolutely none across the board. Do we see that? Do you see what I see? So I have positive, negative, imaginary, and I have my total. How many roots am I supposed to have total?
4.
I'm supposed to have 4. So I have to have 4, but I have to have 4, 2, or 0 positive roots. I still have to have a total of 4 every time. How many negative roots am I allowed to have? 0 every time. Do we see that? So how many imaginary are left for the first case? 0. How many for the second?
2.
How many for the fourth? Third? 4. Which one is it not going to be? It is not going to be this one because in order for it to be the last one, I have to give you at least one of the roots, right? I didn't give you any of the roots, therefore you cannot do the problem. Which means, can you see it when you graph it? If they're all imaginary? So you can't do synthetic division if I don't give you an imaginary root. True that, right? Only if you have an imagination can you see it. I'm sure people in the 70s saw it.
Oh, they saw a lot of it.
Yoder.
So, you either have to have 4 positive or 2 positive. So now what are we going to do? We are going to graph this bad boy. So if I graph this bad boy, this is my function. I'm going to menu, zoom, and I'm going to go to my standard window size because this is what your graph is. When you graph it, this is what it looks like. Do we all see that? Now, I can go all the way out here to 80. I can make this be a negative or positive 81. And do I see anything? No. Do we understand that? Which means, what is my case here? Using Descartes, what do I got going on? I'm going to have this right here. This is my solution. I'm going to have two positive, I'm going to have two imaginary. Do we all understand that? Okay, well now I need to figure out what's it going to be. So based upon that, now I need to go back to my P over Q values. So looking at my P over Q values, I'm going to go back to my graph, and I'm going to graph this, and I'm going to do my menu, and I'm going to do window settings, and I'm going to go from -5 to +5 by increments of 1. Why am I doing that window? That way I can see it a little bit better here. Do we understand that? And if I wanted to, what I really want you guys to understand is where are my x's at? -5 to 5. Where are my zeros at? Between what two values? Between 0 and 1. Holy jeepers, does that give me a lot of info? Because that says that all of these are out for my P over Q values. That all of these are out. Why? Because anything above 1 is not going to work. Correct? Because 4 over 3 is larger than 1. That's 1 1/3. Right?
But they're all negative.
Well, half of them are negative, so that throws out the other half too.
You're saying 1/3 is more than.
I'm saying 1/3 is still possible. I'm saying 2/3 is still possible. The ones I've crossed out are not possible because they are larger than the value 1. So if I look at my 7s, anything above 8 7s is larger than 1. It's thrown out. If I'm looking at my 21st, anything above 21 is going to be thrown out. We all understand that. So now I'm going to go back to my graph. And now I'm going to cheat, and I'm going to use the 0 function. So menu, analyze graph, 0. And I'm going to go left bound, right bound, there it is. So there's 1 0. And I'm going to do that process again. And there's my other one. Now, what I need to know is in all my P over Q values, which fractions give me those two decimals? Well, what's 0.667 approximately? It's 2/3. So if I were to actually do menu, trace, graph trace, and do 2 divided by 3 and hit enter, do you see it gives me 1e to the -11? That's as close to 0 as I can get, right? Right? So 2/3 is a root. So that's where you do synthetic division. 2/3. Does that make sense? Because we know that 0.6666666 is going to be 2/3. Now, I need a fraction that is close to 0.571, or that is 571. So if I go back to my list, I want a fraction. I know this one works. 1/3 is not. That's 0.3. 1/7 is not going to be close to a half. 2/7 is not going to be close to a half. 4/7 and 5/7 could be close to a half, right? 121, none of those are going to be close to a half, right? Do we see that? Do you see how my brain's thinking? The only one that could be close to a half would be the 10 over 21, right? Do we see that? I'm using my brain to take out of my P over Q values, what is that possibly going to be? So I come back to over here, and I'm simply going to do 4 divided by 7 and hit enter. Well, what is 4 divided by 7? 0.571. Is that my other 0? Yes.
What's the?
That's scientific notation saying it's as close to 0 as it can get because it's negative e to the 12. Okay? So now I have two values that I'm going to do synthetic division on. I need to have a chat with my computer. It's making me mad. It might talk to me. So root 1 is going to be 2/3, and root 2 is going to be 4/7. So you do synthetic division of those two values. When you do that, you're going to come up with something that's degree 2. Now, what are my other two roots? Imaginary. So how do I get my other two roots that are imaginary? X equals negative b plus or minus squared root b squared minus 4ac all over 2/3. What?
So, when you circle the four different fractions out of all those cubes, why do you choose 2/3?
Because 2/3 is 0.6 repeating. And that's 6. Mark will be on board right now.
Next one.
Oh,
Should be nice.
and then these two were my possibilities that were close to half. This one over, this was the only one that worked. Okay. All right, I'm done. I just wanted to briefly go over to you guys what you to do. Any other questions over the two worksheets? Finish it off. Well, finish it off by doing synthetic division. Okay.
Okay.
For what? 2/3? Yes, you do. Use your calculator. It's adding and multiplying. You can do it.
I got 80 and 80, but one, they're both positive.
Check your sign. Okay. 4.